Welcome to today's session with Dr. Danny Reible. We are continuing the interview series for AIChE's 50th year of the Environmental Division. 2020 marks the 50 years of the division, but it also marks 50 years of the U.S. Environmental Protection Agency, the NEPA Act, as well as the Earth Day. So we have a lot to celebrate regarding environmental issues and environmental laws that have come into place. So that's why we are continuing this series. And today I have the pleasure to have Dr. Danny Reible from Texas Tech University. Dr. Reible, why don't you go ahead and introduce yourself?
So I'm Danny Reible, and I've trained as a chemical engineer. All of my degrees are chemical engineering. I completed my PhD in 1982 formally, although I actually defended in 81 and began to teach at Louisiana State University. Ultimately, 20 plus years later, I joined the University of Texas. And since 2013, I've been at Texas Tech University, where I'm the Donovan Maddox Distinguished Engineering Chair and also the Paul Whitfield Horn Professor. I have appointments in both civil and chemical engineering. My work is primarily focused and has been throughout my career on environmental engineering.
Thank you so much. A fellow Tiger, I also went to Louisiana State University for my PhD degree, so we have a great connection there as well. So you
spent 20 years teaching at LSU in chemical engineering before I saw the light and joined civil and environmental for the rest of my career. Oh, excuse me. There's phone calls, but they.
So you mentioned environmental engineering as your passion, if I may take that. What has been the work that has defined your career till date?
So all of my work has been focused on the fate and behavior of contaminants in the environment. I really had two frustrations when I was an undergraduate. One is that I went to a school where there was a lot of focus on practice of chemical engineering and the empiricisms in chemical engineering. And I kind of thought that's all chemical engineering was initially. That was my own naivety, but I did learn in graduate school that there is a strong foundation, even more so than many other engineering disciplines. The other frustration that I had, though, is that I could never get overly excited about chemical engineering in boxes, as I refer to it, which would be such as process control units or even units and processes of any sort, except when they're outside of that box. And when in graduate school, I became interested in and pursued studies of fate and behavior of contaminants in the natural environment, in particular in the atmosphere. And that was just so much more interesting to me in this uncontrolled environment as opposed to within the boxes, which you have so much more control. And so that was very exciting to me, and my love and enjoyment of environmental engineering, my passion for environmental engineering really began at that point when I started seeing the applications of chemical engineering to the natural environment. And my career has been focused on that. And although initially I began in atmospheric studies, within a very few years after I left graduate school, I became more and more involved in soil and sediment contamination. And in fact, in the late 1980s, after being in the university as a faculty member for a little more than 5 years, actually closer to 7, I suppose. It was right about that time that I had a consulting opportunity to look at a contaminated sediment site, in this case, which was New Bedford Harbor in Massachusetts. That led to basically a focus of my entire career on contaminated sediments. It also led to a lifelong interaction with Louis Thibodeau, who was my colleague in working on this consulting job. And in fact, I believe that he was the one that convinced me to work on it with him. And so that consulting job actually developed into both the focus of my career and as well just a lovely lifelong relationship with Louis Thibodeau, who unfortunately passed away earlier this year.
Yes, it was very sad to hear about him. I didn't take his class, but he was definitely a very enjoyable character to interact with at LSU. Um, you have worked in the Gulf Coast mostly, like Louisiana State University and Texas, the universities in Texas. And the Gulf Coast has been predominantly industrial areas. So, do you have any interactions where the environmental policies and environmental impacts, where what would be your take on how the Gulf Coast has been looking at the environmental issues?
Well, I guess I should start by just saying that it's interesting that much of my work has been focused on the problems of the old industrial harbors, as I said, contaminated sediments. And when we look in the Gulf Coast in particular, a lot of that industry is post-World War II. And while there's a lot of concerns about the environmental impacts of that industry, it's quite a different level of concern than when we look back to the Upper East Coast, for example, the New England area, and you look at a place where industry has been in place for several hundred years. I can assure you that the environmental impact of what we've been doing since World War II is very tame in comparison to what we used to do in the 1800s and in the early 1900s. And so actually a lot of my professional activities have been driven by the problems of the old industrial harbors in the Northeast and the Midwest and along the Great Lakes, and to some extent in the Pacific Northwest, interestingly. Even though my paycheck was always coming from an institution along the Gulf Coast. So let me just to rephrase that. I have a lot of my work has been focused in the old industrial harbors, the old industrial rivers, where the Industrial Revolution first took place in America, the Northeast, the Midwest, and the Pacific Northwest. And so even though I was working for institutions along the Gulf Coast, I've most of, again, my professional activities have been driven by problems that were elsewhere.
Oh, that
Go
is
ahead.
a very interesting observation that you put out there, that there is a post-industrial or post-World War II era and the pre-World War II era. So how has the environmental protection laws or regulations helped in putting things in perspective with regards to that, like we talk about grandfathered in companies and those kind of issues. What's your take on that?
Yeah, so certainly there's been a lot of development post World War II in the Gulf area, and that led to a different types of contamination. And so, for example, some of the issues that really came to the fore in the 1960s were the problems of the use of polychlorinated biphenyls. Mercury became heavily used during that period. But you still have had a level of activity, a level of performance in the environmental community that is still far better than it was, say, 50 years earlier. But it had its own special problems. And when we're dealing with contaminated sediments, we are mostly concerned about these persistent hydrophobic chemicals. And that's why PCBs and mercury have been even more important. But even there, again, a lot of the challenges are in the old industrial areas in the US, the Rust Belt, if you will, the Northeast and the Midwest. The Gulf Coast is not without its blemishes, of course. There's certainly been problems, and we continue to have to manage them. because of the importance to industry, it's often viewed that the Gulf Coast is perhaps not taking it as seriously as some of the Rust Belt. Um, but at the same time, I think there's no desire on the Gulf Coast to chase industry away and create a new Rust Belt. Um, so I certainly see these issues. But it is interesting that almost all of my professional activities have been driven by the old industrial areas. And in fact, I guess I often would say that my work, I'm stuck in the mud looking backwards. I'm looking at legacy issues, often 50, 75 years ago, that are still problems because these are very refractory contaminants. And again, stuck in the mud because that's where these contaminants reside. So, stuck in the mud looking backwards. It's not a very forward looking approach, and hopefully it's something that I can say about myself and other people don't say about me.
Uh, no, definitely. So what are the impacts that you have seen, like the sediments? What are the impacts that maybe, um, whether it's human health impacts, whether it's environmental impacts? What are when you mentioned fate and transport, what does it actually mean? What is the impact that we are looking at?
Okay, so first of all, there's the environmental impact, and some of the challenges are simply because this material that are of primary concern are so refractory that there's still a problem. I sometimes say that I wouldn't have a career if it weren't for the years 1965 to 1970. We seem to have done an awful lot during that period with releasing these refractory chemicals into the environment all throughout the US and throughout the world. And, and much of what I've been doing is trying to manage those. I'd say that the impacts are interestingly generally not to people because most of the time people don't directly interact with sediments. But it's the first level of impact is to the ecology of the rivers and harbors. And then it does impact people ultimately, but through fish that might become contaminated with these organisms or excuse me, with these contaminants. You tend to, it is somewhat more indirect, however, than many of our environmental concerns. And that's one of the challenges with sediments is trying to connect the dots, if you will, connect the contamination to negative impacts, particularly to people, because it has to be to people before things like the Superfund laws kick into place. There are other laws that manage sediments, but if in particular the Superfund laws, it's all about what are the impacts on people. And so in terms of chemical engineering, how have the work that I and others have done helped address some of these problems? I'd say that's almost where the biggest impact is because these are extremely difficult problems to deal with. What do you do with 30 miles or 50 miles of river that's contaminated as opposed to a simple, relatively simple 2-acre contaminated site? I can dig up that contaminated site and manage it pretty easily. I can't do that to 50 miles of river. You also, the cost of minute you're talking about such a large river, the volume, just the sheer scale of the problem makes it incredibly expensive. And so the biggest impact of our efforts have been to try to mitigate the contamination, but do so in a manner that is more cost effective. And largely that has come down through my career to trying to deal with these contaminants insofar as possible in place or in situ. How do we manage these in a more cost effective and naturally consistent manner as opposed to what we would do with a 2-acre contaminated site? We dig it up and haul it away. Not going to do that to 50 miles of river.
That's very important and very important observation. So one question that comes to my mind that if you have done this to rivers, have you also considered it for seas and oceans? Because when we see and again I come back to the Gulf Coast, but also other areas where when let's say a hurricane is coming in and there is storm surge, so there is possibility of picking up what's on the sediments in the ocean or the seas. Any thoughts on that?
Yes, certainly these are issues. So, for example, I've been part of an effort for several years that has been examining some oil contamination in the Gulf that resulted from a hurricane causing a subsurface landslide that basically destroyed um, a production rig and opened up a bunch of wells and trying to manage the contamination that resulted from that and potentially continues to occur from that. So certainly these are issues in the ocean as well. But there is, perhaps sadly, but there is a certain amount of truth to that adage that dilution is the solution to pollution. And one of the reasons that we tend to work a lot less in seas and oceans is that by the time the contamination has gotten there, it has been diluted to the point where it makes it even more difficult to identify, one, how much impact you actually have, and two, what is a feasible alternative to do anything about it.
Yeah, that's I would probably agree with you that dilution is probably a solution in some cases.
Well, I wouldn't say it was a solution, but there's a grain of truth in it, in that uh, when there is dilution, one, we have a harder time identifying what are the negative impacts, and perhaps the negative impacts have been mitigated. Certainly, natural attenuation and dilution or natural attenuation by dilution is a process that can mitigate and limit the negative impacts of pollution. Uh, but it also makes it, to the extent that dilution occurs, it also makes it much more difficult to try to have reasonable approaches to address it. So I wouldn't call it a solution, but there is certainly some truth to it in that, and I guess somewhat facetiously, I might say that many of the rivers and lakes, that if we actually had a lot of dilution in those systems, if we had a very dynamic system, if we had a lot of sediment erosion, we might not have a sediment problem to deal with because it's been distributed all over
Yeah.
the seabed.
So, what at this point of time, we have had 50 years of environmental laws, but we have been working on environmental issues probably far beyond that time frame. What do you think, looking ahead, are some of the pressing challenges with environmental issues?
I think we are always going to be facing a conflict, at least friction, between population growth, the desire for goods and services by that population, and the potential negative impacts. When we think of environmental impacts, it's always really about mitigating the human influences. And we can always do a better job. We've continued to do a better job, but we're also facing a continued growth in population, and that exacerbates any problems we do have. It is always a effort of two steps forward and one step back, and sometimes it's one step forward and two steps back. But we are always going to have that conflict because we're not. We our presence here. I think my friend Louis Thibodeau said it once. Phrased the term that we are, and therefore we pollute. Something to paraphrase close to that, and so the more people of us like that, as much as we try to control our activities, we are making it harder and harder. And luckily, we need chemical engineers to continue to stay ahead of the game to try to minimize that impact of growth. But there's no question our environmental challenges would be a lot easier if people weren't around. We have seen the problem, and it is largely due to us.
And one of the emerging problems that we are dealing with the environmental division, we are starting to look more programming in that area, is the issue of plastics and waste plastics. Plastics are everywhere, and it's being found in water. And to some extent, one of the other people that I interviewed, Mary Ellen Turns, she said that plastics is not considered that much of a problem because it's not toxic per se, but it is creating issues in the environment. So what are your thoughts about plastics in the media, multiple, like both soil and water?
I think it's perhaps a perfect example of what I was just talking about, is that there are a lot of advantages of plastics. It's provided a lot of positives for us. It's allowed us to reduce the weight of automobiles. It's allowed us to reduce the weight and therefore fuel usage in airplanes. And it's certainly of a lot of convenience to movement of even things like water, or certainly there is a lot of positives associated with plastics, but certainly there are a lot of negatives, especially when it's not managed properly, the waste isn't managed properly. And yes, on a per pound basis, it's not nearly as toxic as something like the polychlorinated biphenyls that I work with. But when you think of the large, just incredibly large amount of plastic that we generate, it's certainly a problem. The picture behind me is a picture of the Yangtze River leading down through the Three Gorges down to the Three Gorges Dam. And I had occasion to take a boat down that river a couple of years ago, and it's actually quite amazing how much plastic waste is floating along that river. And it's perhaps sad to see. And again, not directly toxic, but it is unfortunate. And I'm certainly wholeheartedly behind efforts to minimize the use of plastics to the extent that where it's really useful, we should make use of it. Where it's a lot of just generates waste, it's not very helpful. And then secondly, to better manage whatever plastics we do generate.
Thank you so much on that thought. So the next question that I have for you is, I would ask you to wear your educator hat and ask you, how do you make your students aware of environmental issues, and how have you seen students probably change over time? And what do you think is the future for us as educators to bring environmental awareness as well as education into chemical engineering and the engineering field in general? I would open it to engineering because you have so much experience with other interdisciplinary activities as well.
I'm certainly a strong supporter of interdisciplinary, transdisciplinary activities, and contaminated sediments work is kind of defined by that. But with respect to your question, I often feel that I'm not leading the education of my students. They're leading my education. I found it interesting, and perhaps it's a challenge that we need to understand better. But I changed in mid-career to an environmental engineering department or group within a civil engineering department from teaching in chemical engineering. And I would say that at least at that time, I was struck by the difference between essays that a student might write to gain admission into chemical engineering were often about their professional goals, their career plans, how education would help them in achieving their career goals. And quite honestly, the essays from the students seeking application into environmental engineering were more about, I want to save the world, and I think by going to graduate school, you can help me. It was such a different tone. And so I would say that I see, and I think that's also changed over time, is that in the past 10 to 15 years, we see even more of that students of today are much more interested in changing the world, and they think that I can help them do that. And as a result, they're pushing hard as opposed to me leading them. They're very much leading me. I am trying to help the situation, and I currently have a National Science Foundation grant to develop or to better train engineers through what I've called developing reflective engineers through artful methods. We're using artful methods, including art itself and the arts and humanities, to try to develop engineers that are more thoughtful, reflective, introspective, and see some of the more ill-posed, uncertain problems that they're actually having to work in, compared to what we often teach them are closed-end, well-defined homework problems. And so I'm trying to do, to some extent, trying to help push students along to make them more reflective and better, more cognizant of and more responsive to the environment and to human needs. But again, I think that I'm being drug along just as quickly, if not faster, by the students themselves. There's been a real change, and particularly students that are drawn to environmental engineering and environmental chemical engineering.
That is very interesting to know. How I would definitely like to know more about the artful methods of bringing up engineers. That's very interesting.
Happy to discuss it with you at some point.
Absolutely, absolutely. The next question, and this is coming back probably to the environmental division. What has been your interaction with the environmental division at AIChE, and what do you remember about your time that you have spent with the division, if you have any thoughts on that?
Oh, I certainly do. And AIChE was really important, especially to my early career. I taught in chemical engineering, and the American Institute of Chemical Engineers was like home to me. I had an opportunity through a mentor, an early mentor, Jack Hopper. And when I think of my mentors, Jack Hopper and Louis Thibodeau, it's just so important to have good mentoring, and I try to do the same for the junior faculty that I interact with. But I would encourage any young chemical engineer to find those mentors that are really helpful to them, and try to take advantage of the opportunities that they provide them. But in my case, Jack Hopper was very active in AIChE, and he encouraged me to become active and helped me to become active, and gave me some opportunities that I wouldn't have had otherwise, including I chaired a national meeting in the early 90s, maybe 10 years into my career. For the next few years, I served on the executive board of the programming committee of AIChE, including chairing the executive board of the National Programming Committee at one point in the mid-90s. And that was just a fantastic opportunity to try to understand and to try to help manage the diversity that is chemical engineering and how we present that discipline to the world. It was somewhat after that I actually had my largest activities and interactions with the environmental division, leading ultimately to being chair of the environmental division in the early 2000s. And it was certainly an important part of my career as well. Uh, One of the challenges that chemical engineers and AIChE always has is it's a very diverse group. And so the environmental division is perhaps even more than most. We have a diverse group of engineers, a diverse group of interests, and it's hard to find technical programming, for example, which is where a lot of my activity was within AIChE. It's hard to find technical programming that's of value to the broad range of chemical engineers. But we have great strengths that we bring to environmental problems, and again, it's a continuing challenge in the environmental division to try to appeal to that diverse set of interests within the environmental chemical engineering community and provide programming that is helpful and of interest to them, and at the same time further develop the young faculty. I have to admit that in mid-career in 2004, I joined the University of Texas. And at that time, I shifted from a chemical engineering department as my primary department. I continue to have affiliations with chemical engineering, but my primary department became civil and environmental. And it was certainly appropriate. I was focused in environmental, but it's interesting that it's also a little different group of individuals and perhaps not quite as diverse as the AIChE community. In many ways, it was easier to interact with like-minded individuals in that community than it was in AIChE. So this is a continuing challenge for the environmental division, but I'm perhaps somewhat disappointed that as a result of that move, I've kind of slowly moved away from the environmental division and AIChE, and I'm not as active certainly as I once was in AIChE or the environmental division. But of course, once you become chair of the division, you go through a multi-year process of that. You're involved in various roles within the environmental division or of any organization. It's pretty natural to step back and say it's time to take a little break as well.
Absolutely. But again, nowadays, like NSF has in its top 10 research ideas, the concept of convergence. And I think it's time for us to bring AIChE as well as the civil engineering and environmental engineering communities together, not only within the AIChE, but also external to the communities to bring things together and work together towards common goals. I think that's one very good thing that NSF is promoting the convergence research.
There's no question. And I would say that environmental engineering is actually a natural for that and always has been. And I would say that as long as we're driven by common problems, then it's quite natural to say what is the convergent research and the disparate disciplines to try to address that. In a way, it's kind of difficult for our traditional organizations to deal with that because they're perhaps, AIChE by definition is discipline driven as opposed to problem driven, and it requires some thinking changes on the part of the organizations to how can we be more embracing of the broader community. And I think the easiest way, again, is through being driven by problem and recognizing that there's a lot of disparate voices that need to address that problem. One of a really enjoyable community to participate in, and I'm sure you do as well, is the American Association of Environmental Engineering and Science Professors. We're driven by a common problem. It was more of environmental engineering first, academia first, not the disciplines. So disciplines have largely aren't apparent in that organization. Mm-hmm. But for the traditional engineering disciplines, we were organized initially by disciplines. We were organized by those silos, and sometimes it's not so easy to break out of those.
Mm-hmm. One thing that I would like to mention at this point is that the AIChE's environmental division is looking for volunteers as you know. Uh, any young professor, any young researcher from universities are welcome to come and join the division. It's a very warm, welcoming group. We still are very active, and we try to keep up with the latest in programming, as I mentioned, waste plastics, food, energy, water nexus, as well as we are also heavily programming in carbon dioxide related issues. So I want to put that out there from your institution or any other institution, any young members that we can recruit. We are always looking forward to that. And people can start from programming, as you mentioned, the technical programming. It's as simple as asking us to ask about how to get involved. Chairing and co-chairing of sessions is how we all start within the division, and then we go along the way. We learn what the division works like, and then we go through the different ways. It's very easy, very comfortable, and very rewarding experience, I would say, to join the division.
I would, fully agree, and I'm still a member of the division, just not as active as I once was. But I should develop my mentoring skills more by ensuring those that have an interest in chemical engineering community do participate in the environmental division.
No, that's definitely, and thank you so much for your time. Of course, like it's been so many years, but thank you for responding to my call. It is really important for us to know how the division, as well as how the environmental setup of today's world has been defined by faculty, esteemed faculty like you. And this video is going to be put out on the web for everyone to see and to learn from, and to any questions that they have, anything, they can go back and see, okay, this is how the things have happened over the past several years. So that's why I thought of making it into a video recording, so that we have it for all the membership, as well as for anybody to celebrate the 50 years of the division. So any concluding thoughts, any comments, any remarks from you,
Well,
Dr.?
I just hope you can edit out a few things like the phone calls in the middle.
Well, that's what the COVID situation has made us. We are available all the time, I guess. So, but thank you so much, and thank you for your time. And we'll probably see each other in the future, sometime in person, as these things.
Someday soon, we're going to have a chance to go in person. I have to admit that I have very little interest in attending conferences that are totally by Zoom. Certainly you can't avoid meetings and